Hello and welcome to the Fortress West Point Sprint 4 review video. Our goal for this sprint was very dynamic and had consisted of numerous interrelated pieces. We worked in coordination with the history majors to finalize the historical narrative conveyed through the app, place our AR objects and historical markers at Trophy Point, made important improvements to our UI, and achieved our single largest goal of the entire project, which was getting the Great Chain to display across the water. We also developed posters for our American Revolutionary War Museum and Projects Day presentations and began coordinating the execution of both events. Overall, we met our goals, but there were a few other subtasks that came out of that that we're going to have to address in the next and final sprint. We worked several hours beyond our sprint capacity, primarily due to the fact that certain tasks took longer than we had originally expected, and then unanticipated subtasks popped up as we progressed toward our goals.
Hello, my name is Craig Sheets.
And I'm Tyler Wilton.
In this sprint, we worked on image recognition and placing the Great Chain.
We started our image recognition process using the ARKit 1.5 within the Xcode 9.3 beta. This allowed us to build apps which could be used with devices running the iOS 11.3 beta, which was released February 21st, around the beginning of our sprint. We started experimenting with image recognition capabilities within the Capstone workspace, using distinct objects to test how accurate the recognition was, and then once we were able to recognize images, we tested those recognized images as anchor nodes to place our augmented reality objects. Here we are in the testing environment. We are starting our image recognizing process by looking up at the data box. Now, once we recognize the data box here, we will attach our AR object, in this case being the sphere, to the node in the center of that image. It anchors to that, and therefore it will not move, and we can move around it without worrying about the sphere moving. Now that we were able to recognize images and place objects in a set position with relation to that image, we went out to Trophy Point to determine if ARKit 1.5's image recognition was powerful enough to recognize details within a larger environment from across the Hudson. To do this, we took a picture from our fixed vantage point on Trophy Point overlooking the Hudson, and then cropped an easily recognizable subimage, which we believe contains features which will be most consistently visible year-round. The images here represent our vantage point. The image on the left is the actual image taken, and then the image on the right is the subset of that image taken, which is going to be the image that is going to be recognized by the program. As you can see, the image on the right has two distinct buildings in it, as well as a clear riverbank and a clear ridgeline. These features will allow ARKit's image recognition software to determine our environment and place an anchor point where we would like to place our chain.
As you can see here, ARKit's image recognition software has recognized our image and placed an AR anchor node in the middle of the image. In this test, we used the default image of the spaceship, which you can see is hovering at a very stable position on our image. Throughout this process, as we were trying to display the Great Chain, we ran into possible conflicts between the software which our 3D modeler Jason Chambers used to create the chain and what we were using to display and edit the chain, which was Blender, before we imported it into Xcode. We ran into trouble separating the two forms of the chain with the OBJ file that Jason Chambers sent us, so we contacted him and requested that he send us a model in a different format, a collada file, .dae, which we thought may be more compatible and easier to use with Blender. Once we had this, we were able to resize and manipulate the two versions of the chain, although we did have to go back and re-add the textures to each individual link and log in the chain. As you can see here from this early attempt to display the chain, there are no textures. Additionally, the chain is appearing directly where the user opens the app, which means that it is set at the default origin of the user. Now that we had the chain displaying, we were able to manipulate the chain within Blender and change the coordinates so that when it recognized the image of the houses on the hill, it was able to display the chain to the bottom left in the position that it would be set on the river. Many of the roadblocks and obstacles which we came upon during this sprint were due to the recency of ARKit 1.5 and being newly released and still in the beta stage. Due to this fact, there was little supporting documentation or chatter on message boards such as Stack Overflow for us to use when we were troubleshooting. Additionally, we ran into several troubles when displaying and manipulating our 3D model of the Great Chain, which stemmed from a combination of using different software to edit the chain than what was used to create it, as well as our relative unfamiliarity with 3D modeling and using Blender.
Moving forward, we will refine the placement of the Great Chain on the Hudson and attempt to make it more stable by possibly adding more anchor points, which will utilize image recognition capabilities of ARKit 1.5. We will add our Stand Here AR object functionality to the fixed location on Trophy Point, from which we have been implementing and testing the placement of the chain.
Hello, my name is Cadet Spencer Welton. For this sprint, I was responsible for getting the 3D objects we would use to represent our characters ready to implement into our app. To achieve this, I had to convert the models we received from TurboSquid into a format that would be compatible in Swift, the language we are using. I converted the models using Blender and was able to import it into Xcode. In Xcode, I was able to further reposition and scale the models to the dimensions needed. Layers were also added to give the models a realistic look. I also attached the plaques we plan on using to the models. These plaques will be used to tell users the stories of the chain. These were able to run on our iPhones and gave us the look we were working towards. For the next sprint, we plan on having the models activate according to specific GPS locations we've chosen.
For this sprint, Alex and I were working on modifying our UI design based on the user feedback from the user testing that Tyler Wilton conducted last sprint. Now our app originally would have a bar at the top here that had a navigate and a next button, and the biggest feedback that we got from the user testing was that the next button was not very intuitive. Essentially, the next button would just rotate through our different hotspots. And so in order to fix that, we added this drop-down menu where you can click it and actually pull up the different hotspots. This is Battle Monument, we have Kosciuszko's Monument, we have Macon, and then we have Trophy Point. Secondly, we also removed the navigate button up in the top right and now have this icon on the right side of the screen, right above the AR camera button, that will allow you to navigate to the location you have selected. And as you can see, it is fully up functional. You can pull up different hotspots and navigate to it. And the AR camera button still works. As you can see, if you're close enough, it pulls up the AR part of the app, which is still just a placeholder rocket. From here, Alex and I will be adding a help menu button that will allow the user to pull up a guide for how to use the app in case the app is still not intuitive for the user. After we complete that, we'll then move into implementing Spencer Welton and Craig Sheets' part of the app into our UI design, which would be actually displaying the Great Chain when they're at the Trophy Point hotspot, and when you are at the other hotspots, you'll see the different markers that Spencer Welton is working on.
In working towards developing our presentation poster for the development process, I had to manage being technically specific enough for those familiar with Apple and AR technology to understand our methodology, while being simple enough for those entirely unfamiliar with the concept to comprehend what we did as well. I worked in close coordination with the history majors on the historical context poster, and we came to the same dilemma of trying to provide enough information for situational context, but also without overwhelming the reader. One of our posters has been approved and finalized, and a work order has been submitted through Vios, and the other poster is pending advisor approval, but a work order will be submitted shortly as well. Looking at our project roadmap, we believe we are on glide path to have a working demonstration completed no later than 15 April for the American Revolutionary War Museum presentation, and then have a complete application done by 30 April for Projects Day. We need to refine aspects of the Great Chain, add in a few supplemental features, and finalize our Projects Day demo, but we believe that the greatest learning curves and obstacles are behind us and that we will ultimately be successful.